Hello, we're going to go through a few pH calculations. This is looking at problem number 10 on page 17. And the various equations that you would need to know are up here on the top right here, and these are on your equation sheet as well. So I'm going to try doing this with this calculator and see how this works. It's a lot of just plugging stuff into a calculator. So right here, first thing you want to notice is that you want to recognize is that the H plus concentration is the same thing as an H plus concentration. And when you ever see something in brackets, that means that you're describing the concentration in molarity. So this means that my H plus concentration is 2 times 10 to the negative fifth molar. And let's say I try and find the OH. If I look at my equations I know that I'm given this, that the H plus concentration times the OH concentration is 1 times 10 to the negative 14. So if I want to solve for my hydroxide, I can take 1 times 10 to the negative 14 divided by my hydrogen concentration. So let's try plugging that in our calculator. So we've got 1, and then what I would recommend doing is using your EE button. In this case, it's labeled EXP, or yours might say capital E or capital EE. So 1 E 14 negative. So that stands for 1 times 10 to the negative 14. And then I'm going to divide it by, let's see, where's my dividing number? There it is. Okay, divided by 2 E negative 5. And I'd recommend using that EE button because then you don't have to be as careful about parentheses. Otherwise, if you type in 2 times 10 caret negative 5, you'd have to be really careful about putting parentheses around this whole deal. If you use that EE button, you don't have to worry about the parentheses. Okay, so now let's hit equals, and I'm going to have this long number, which is 5. Let me count the zeros first. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this is 5 times 10 to the negative 10th. That's my concentration of OH. And then for my pH, pH is the negative log of the H plus concentration. So I'm just going to take the negative log of this number right here. So let's go back to our calculator, and I'm going to clear things out, and I'm going to find the log button. And depending on how your calculator works, sometimes you hit, let's see, where's my log button? Sometimes you hit log first, there it is. Or sometimes you hit it afterwards. It looks like in this calculator I'm supposed to type in the number first, then hit log. So I'm going to clear it out. I'm going to type in my number first, which is 2 exponent negative 5, and then I'm going to hit the log value. And the pH is the negative log, so I'm going to take the negative of whatever this number is. So instead of negative 4.7, I'm going to put positive 4.7. So my pH is 4.70, because I think it was like 698, so I rounded it up there. And then my POH, I could use two different things. I could either take the negative log of the OH concentration, or I could use the fact that pH plus POH equals 14. If I do that one one's probably a little bit easier, so I can do 14 minus 4.7. I should get, what, 9.3 as my POH. And then thinking acid, base, or neutral, remember things with a pH below 7 are acids, pH above 7 are bases. So this one has a pH below 7, so this one is an acid. All right, so let's try that again with one down here. Because what if let's see what we know. So let's say we know the pH, so we can find the POH, just like we did up here. pH plus POH is 14. So my POH is going to be 14 minus 6.25. So that would be 7.75, I believe, if I'm doing my math right there. And then now how do I work my way backwards to find these concentrations? Well, if the pH equals the negative log of the H plus, what does H equal? Well, you have to figure out what the inverse of the negative log is. And the inverse of the log is doing 10 to the power of something. So if I raise both sides 10 to the power of something, I end up with my H plus equals 10 to the negative pH. that's the way logs work, because I want to make this positive. So let's say my H plus concentration is 10 to the minus pH. So I go and plug that in my calculator. I would work my way backwards here and say, okay, my H plus concentration is 10 to the negative 6.25. But I don't want to just leave it that way. I actually want to figure out what that is. Let's go back to my calculator, and I'm going to do, let's see, 10, depends on, again, what calculator you have. This one's got a 10 to the button. I think I need to type the number in first. So I'm going to type in 6.25 and make that a negative, and then I'm going to hit 10 to the, and that is going to give me an answer. So this is 5.6, whoops, and it disappeared, 10 to the minus 7. Make sure you're careful about reading your calculator. You see how there's the little exponent there at the end? A lot of times people miss that. Like they just look at the first few numbers and they ignore the ending. So it's 5.6 times 10 to the negative 7. So that E represents times 10 to the. And then you do the same thing for your hydroxide. I want to take the, here, let's write over here again. So I say the same can be said for hydroxide. The hydroxide concentration is going to be 10 to the minus POH. Okay, so I'm going to go put this in my calculator, 10 to the negative 7.75, and then let's check this out. And again, everyone's calculator is different, so just kind of to play around with it a little bit. In this calculator, I type in the number first, so 7.75, and make it a negative, and then I hit this 10 to the X button, and that is going to give me 1.78 times 10 to the negative 8. So don't forget to look at the ending here. So this was 1.78 times 10 to the negative 8th molarity. I don't know if you guys notice when you look at these two numbers, the exponent should add up to 15. So 5 plus 10, 7 plus 8, they add up to 15. And then this one, again, the pH is less than 7, so it is also an acid. Okay. So everything is then some variation of this. Now that you know how to go one way, you can go the other way. So like here, if I know the POH is 9.2, the OH is going to be 10 to the negative POH. So it's going to be 10 to the negative 9.2. So plug that in your calculator, figure out what it is. If I know the POH, I can find the pH using this relationship that pH plus POH equals 14. So my pH would be 4.8 here, and then if I wanted to find my H plus concentration, it'd be 10 to the to the minus pH, so that would be 10 to the minus 4.8. But don't leave it like that. Actually, plug it in your calculator and find a number for it there. So that's those ones. And then looking down here at number 11, this is an interesting one to look at as well, because you should discover something about how logarithms work and why the titration graphs for acids and bases look the way that they do. So make sure you try this one. And to clarify, just make sure we're clear on what B is saying. So this A is saying what's the pH of a solution that is 0.1 molar H plus. And then B says if you take this 100 ml sample of 0.1 molar and you add 100 mils of water to it, now you're going to have a 200 ml sample total. And so if you're trying to find the new molarity, you can use M1V1 equals M2V2. So your initial molarity would be 0.1, your initial volume is 100 mils, your final molarity is your unknown, and your final volume is 200 mils. You should be able to do this one in your head, though. It is a 1/2 dilution, so it's going to be half of whatever it started with. So you doubled the volume, so the concentration must be cut in half, because concentration is molarity divided by liters. So if this one goes up, this one's going to go down. So it's going to be 0.05 molar, and then you want to find the pH of a 0.05 molar solution, and you should find that even though the molarity cuts in half, the pH does not change by very much, and that's the nature of these logarithmic scales. It has to change, the concentration would have to change by tenfold in order for the pH to change by 1.